Hello, everybody, and thank you for joining us today. I know it's 11 o'clock, but we will give it a minute or so to let any stragglers come in that might not be prompt on time. So we'll get started soon. Thank you very much. Okay, I think we've given it enough time, so we are going to get started here. Good morning, everyone, and welcome. I'm Charlie Hathaway, Business Development Manager for OEM Contract Manufacturing here at Peerless. We are very excited to host today's webinar on behalf of our Midwest Delta Steam Systems USA distributor, MECTEC, and its founder, Donnie Manternach. Promised I practiced this before. Uh, we're also joined by Bryan Anderson, founder of Delta Steam Systems in Cape Town, South Africa, who will be delivering today's main presentation. It's going to be a valuable session, and we're glad you're here with us. So quickly, our agenda here, welcome and introductions. I already sort of got started on that, but we're going to have a little bit more. We're going to do a little bit of housekeeping about questions, which are hopefully important to everybody here. Donnie's going to do a little MECTEC overview, and then we're going to do our main presentation, why everybody's here, Delta Venturi steam traps, myths, payback, and reliability. And then finally, a Q&A session at the end where Donnie, Bryan, myself, and Chris will be able to answer any questions that you might have. Speaker lineup. I introduced myself, Charlie Hathaway, Business Development Manager, OEM Contract Manufacturing here at Peerless. You're shortly going to hear from Chris Rudnicki, who's our Customer Growth Manager at Peerless. You're going to hear from Donnie Manternach, founder of MECTEC. And finally, Bryan Anderson, founder of Delta Steam Systems in Cape Town, South Africa. So with that, I'm going to pass it over to Chris Rudnicki, who's going to do quick housekeeping.
Thank you, Charlie. Just a reminder, the session is being recorded. We'll make it available to all attendees afterwards. If you have any questions at any time, I know there's a Q&A at the end, but please drop them into the chat and we'll address as many as we can during the session. And with that, I'll hand it back over to you, Charlie.
Perfect. Thanks, Chris. Like I mentioned earlier, first we'll hear a brief overview of MECTEC from Donnie, and then Bryan will take us through today's presentation on Venturi-style steam traps.
Excellent. Thank you, Chris. Yes, again, Donnie Manternach here with MECTEC. I am the Midwest United States representative for the Delta steam trap line we'll be discussing today. And I would like to introduce my business to you. I'll be a resource for you if you have any questions on the product range after the presentation, as well as perform site visits. As I mentioned, we're a small family-owned business based out of Eastern Iowa. We were developed in late 2024 and launched in 2025. And Chris, can you go next page for me?
Sorry about that.
Yep. I mentioned late 2024, the business was developed, launched early 2025. The mission for MECTEC is to bring new solutions to old problems. I've spent 15 years in the steam industry and feel this is a good opportunity for me to bring the knowledge I developed over working with customers and end users across the United States and Canada over the last 15 years and bring better ideas to solve some of their old problems. I'll give you a quick overview of the product range that I offer with my customers, as well as some of the services. I service the biofuels industry, ethanol, biodiesel, institutional, which is hospitals and universities, heavy industrial, as well as the food and beverage industry, and have extensive experience in the processes related to those industries from the 15 years in the steam industry that I have. The product and service capabilities as an organization, I offer engineered mechanical equipment ranging from steam specialties, which you'll hear very much about today, pumps from mechanical to positive displacement pumps, all ranges of valves from control valves, isolation valves, heat exchangers, as well as I do have an offering of steam trap services. So I can do steam system audits for your facility, steam trap surveys, as well as provide engineering and design support for any projects that you may have going on at your facility. And with the ultimate goal of providing your facility with a more robust, more reliable system that helps with your production and your processes moving forward. And with that, I'll turn it over to Bryan. Bryan's going to introduce us to the Delta Steam Line and the Venturi steam trap.
Hey,
Thanks
Donnie,
very much, Donnie.
Excuse me.
Yeah,
Sorry,
yeah.
Bryan. Before we get started on that, can you talk about, Donnie, the best method for the steam trap surveys and what goes into such a thing?
Yes. Obviously, when we perform over the last 15 years, when I've been performing steam trap surveys, my preferred method is ultrasonic and temperature. The combination of those two results gives the best diagnosis of the current operation or current condition of a steam trap in a system. Individually, one or the other gives you an indication, but it's hard to confirm true functionality of a steam trap without the combination of ultrasonic and temperature. I know in the industry or a lot of sites do try to do strictly thermal, and there can be some conflicts that arise from that as relying on just one technology or the other to truly deduce what the condition of a steam trap is.
Thank you. Sorry, Bryan.
Yeah, no problem. Thanks very much. All right, let me get my presentation loaded up here. So thanks, everybody. Nice to be here. It's 5 o'clock in South Africa. So let me just jump through our presentation a bit about who we are and what we do. So we are steam specialists and located in Cape Town, South Africa. We established 1999, so we've got 26 years in the steam industry, and we specialize in energy conservation through steam trapping. ISO 9001 2015 company, and we're the designers and manufacturers of the 20-year guaranteed Delta Venturi steam trap. So our head office, as I said, is Cape Town, South Africa, and our distribution network is spread across the world, and we've got a sales network extends even further throughout the world. I'm going to just briefly touch on some functions of steam traps and just general steam trapping, and then I'll jump into the Venturi steam traps themselves. So the function of a steam trap, as we know, is vent air non-condensable gases. It releases the condensate and gets rid of the condensate as quickly as possible as it forms. Its job is to prevent the escape of steam, which is very important, and to operate reliably for long periods in harsh environments. So conventional steam traps open a valve when the condensate or water is present, and they close the valve when the steam is present. The valve opens and closes continuously to drain the condensate and stop the steam from escaping. So in steam traps, there's many moving parts such as ball floats, inverted buckets, bimetallic strips, bellows, discs, and they cycle open and close continuously as they operate. So just as an example, a steam trap that cycles conservatively 5 times a minute is 300 times an hour, 7,200 times a day, and over 2.6 million times a year that steam trap is cycling. So this continuous cycling movement often results in steam trap failure, often within the first year. So conventional steam traps are generally seen as consumables and need constant replacing. And it's mainly through the cyclical movement of just wearing themselves out that this occurs. So steam trap failure, conventional steam traps fail in one of two ways, either failed closed when the internal mechanisms are damaged, causing the steam trap to be partially or closed or blocked, or they fail open. This is where the mechanisms are damaged and the steam trap fails fully open or partially open and leaks steam. Steam trap failure results in steam wastage, boiler demand increase, water hammer, cracked or damaged heat exchangers, valves, steam and condensate lines. additional boiler fuel usage, pressurization and slowing down of the condensate return system, poor heat transfer and decrease in production capacities, and carbonic corrosion resulting in leaking pipes. So both methods of failure are equally problematic. A typical steam reticulation system is essentially a steam boiler with a main steam line to a steam header feeding the steam system. There'll be steam traps along the manifold, along the steam lines, getting to a heating unit, a heat exchanger of sorts where the steam's been used, which will have a steam trap on it. And all of this condensate returns to the condensate return tank, which is pumped back to the boiler. Most plants are closed loop systems like this. You do get drain to waste systems as well, but all along the system, you'll have steam traps placed to get rid of that condensate and trap the steam back into the system and work efficiently. All right. So just quickly, some types of conventional steam traps. You get ball float steam traps. So this is just a free float steam trap where a ball moves up and down on a valve, which allows the condensate to leave. That valve is often oversized, so when the trap does leak, it fails large amounts of steam. You also get a ball float steam trap with a fixed arm that's fixed to the body of the trap, to the valve assembly, and that lifts and lets the condensate through. This also an oversized orifice. When it leaks large amounts of steam. And generally, these steam traps have built-in air vents, which can also leak steam. The third type is inverted, or the second type is inverted bucket type steam traps, which work on a system where there's a linkage with an arm, and that lifts and allows condensate to move. It's a part that moves up and down. This is the valve assembly. And as this bucket lifts up, as the condensate fills it, that valve assembly will lift off the valve there and allow condensate to push through. And this cycles open, close continuously. All right. And then the next one is probably the most common type of steam trap is a thermodynamic steam trap, which operates with a disc that rises and falls on the seat. So this disc is prone to leakage through either scale or solid particles scratching the seat or disc, or just through self-impact due to its design nature. As it opens and closes constantly, that self-impact creates wear and the traps tend to fail. Thermodynamic traps are probably the most common traps to fail on a steam reticulation system. This is just a quick video showing a thermodynamic steam trap that has failed, and you can see normally the steam is piped back into the return system, so you don't see this, but this is what it looks like. So that trap is just wasting steam. It's supposed to close, wait for condensate to build up, and then pass the condensate, but this one's just passing steam constantly. We actually call it motorboating, the way it up and down, and that's normally piped back into your condensate return line, and it's not seen. So you don't see the waste, the leaking steam in front of you. It's piped back to your boiler system and often just vented out to atmosphere. All right, then the last type is a thermostatic type steam trap. This is a bimetallic type steam trap. It expands, the bimetallic strips expand and contract, lifting the valve assembly off the seat and allowing condensate through. It can also get damaged by scale or particles in the steam system, or just through self-wear, eventually just wears out and starts to leak. And this is a video of a thermostatic steam trap on a condensate return system in a refinery that has failed. Again, that's just a visual that you can see. It's normally piped back to your return system, so you don't even notice that that's happening. You walk past the steam trap and it all looks good and you think the trap's working well, but meanwhile, it's blowing steam back into the steam condensate return system, and it's costing loads of dollars. All right. Then why is there so much steam trap failure? So often there's lack of knowledge or understanding of steam traps. It's just a valve that's in the system, and nobody really knows how to test it or what to do about it. They're often just generally overlooked. Sometimes they're in an obscure or inaccessible position, so they can't be reached to be tested properly. Or effective and correct steam trap test methods aren't used to test the trap properly. This photo just shows a picture of a F&T trap, the ball that's used to modulate the valve assembly that's been damaged by water hammer. So when this happens, this valve would fail in the closed position, and that steam trap would not pass any condensate out. So it's easily damaged by water hammer and then fails closed. So results of steam trap failure are process problems where there's frequent downtime, pressure surges, or slow startup. Distribution problems with steam loss, water hammer, or poor steam quality. There's maintenance problems where there's fewer people doing more work or there's no spare parts available. And then financial losses, there's a high energy cost, high cost of spare parts or replacement parts. The environmental impact where there's unnecessarily high CO2 emissions through failed steam traps. On average, 20% of all steam traps in an industrial plant are leaking, which results in large financial losses every year. We've done numerous steam trap audits around the world, and that 20% is a figure we see quite regularly. We see less and more. So depending on the regularity of your steam trap testing program, you can bring that down a bit if you test your traps more often. But generally, it's 20% failure of the steam trap population on a plant. So steam trap leaks are amongst the most wasteful and expensive issues found in a plant. Even the smallest steam trap leak can cost anywhere between $2,000 and $10,000 per year, depending on the pressure in the system. So Delta Venturi steam traps is the permanent solution to this problem. This is the 20-year guaranteed Venturi steam trap. It's a complete stainless steel trap. It's got no moving parts. There are no spare parts required for the trap itself. There's no more steam leakage. Once it's sized correctly and commissioned, that trap should not need to be touched for the period of the guarantee, for the 20-year period, or even longer. They handle varying or constant load. So any steam system has a varying load. So as your load changes, the trap must be able to handle the load that it does, and we'll explain how it does that in a little bit. They easily handle water hammer because there's no parts that move. They don't get damaged by water hammer. There's minimal maintenance. When we say minimal maintenance, perhaps if your steam system's not as clean as it should be, your water treatment system's not working as well as it should, you might need to clean the strainer mesh from time to time. So it would just mean opening this bottom cap, taking out the strainer, the mesh, giving it a clean, and putting it back again. There's a secondary strainer at the top here. So at the top, there's two strainers in the system, the primary one at the bottom and the secondary one at the top. And this would just be isolating either side of the trap, obviously, and then taking the cap off, cleaning the strainer, and put it back into commission. All right. And then automatic air venting on startup, and it operates on a constant discharge principle. So as long as there's condensate present, this trap will get rid of it. It doesn't work on a blast discharge principle where it waits and waits for condensate to build up and then gets rid of it. It gets rid of any condensate as it's formed at the trap very quickly, which is very good for heat transfer temperatures and that sort of thing. You can
Bryan?
install it vertical. Yes, Chris.
Sorry, quick question. You showed us, 4 or 5 different types of steam traps. The question is, is there a certain type of trap suitable for certain applications, and would Venturi traps work in all applications?
Yeah, so generally in industry, you use specific types of traps for specific applications, where you'll use thermodynamic traps for drip legs and those kind of applications, where on a A heat exchanger, you'll predominantly use a ball float or an F&T trap, floating thermostatic trap, on a heat exchanger application. With these applications, you can use a Venturi trap on all of them. Because of the way it works and the way it gets rid of condensate, you can use them from trace heating through to drip leg and heat exchanger applications. So right across the board. All right.
Thank you very much.
Great. All right. And then just some applications for industrial plants. I think I just touched on it now. So steam mains drainage, drip legs, tracer line applications, and process applications, heat exchangers. That's what I was saying a bit earlier. So a simple comparison between conventional steam traps and Venturi steam traps. Conventional steam traps have moving parts which wear out. We touched on that earlier. Because of the way they cycle and constantly are opening and closing, they eventually fail and wear out. Whereas there's no moving parts on a Venturi trap that fails and wears out. They require spare parts, conventional traps, where Venturi traps don't require spare parts. Conventional traps have poor resistance to wear and water hammer. A Venturi trap easily handles water hammer. Conventional traps generally come with a 1-year guarantee or warranty. With the Venturi trap, it's 20 years. An expected lifespan of 1 to 3 years. Some traps you may get a bit longer, but on average, it's 1 to 3 years. The expected lifespan of a Venturi trap is 20 to 30 years. So it'll outlive most of the pipework in that system. And then conventional traps can fail open and waste steam. With a Venturi trap, a correctly sized Venturi trap cannot fail open and waste steam. So the Delta DSV, which is the model that I've been showing you, is the world's first dual strainer Venturi steam trap. Complete 316 investment casting construction. It's got inline Venturi accessibility, so the trap itself is installed, and if you need to access the Venturi nozzle itself, if for whatever reason, if the system changes in the steam system, the pressure is adjusted and you want to change the nozzle, it's quite simple to do that. While it's inline, you don't have to remove it from the line. And then just an exploded view quickly of the trap itself. This is just the flanged version, but you can see that there's the Venturi nozzle that gets fitted into the body of the trap, and over that goes the secondary strainer. From the bottom is the primary strainer with the caps and the gaskets that belong to it. All right. So the flow through the trap, you'll see, is in the inlet through the primary strainer, through the inlet port, and then the secondary strainer, and then into the tunnel orifice of the Venturi. Now, the tunnel orifice is the elongated orifice of the Venturi trap. And why that's very important is that orifice is quite long to prevent wire draw. Now, if it was a very short orifice, there was a potential of wire draw and widening. But because we make it so long, we have no issue with wire draw. The orifice doesn't widen, and that helps give the extended warranty on these traps themselves. And then obviously out through the Venturi and exits into the condensate return system. I'm going to just show you a quick video of the workings of the trap, and it'll give a bit of an explanation.
Introducing the Delta Venturi Orifice Steam Trap, a unique steam trapping solution designed for multi-purpose steam trapping applications, from line drainage and trace heating through to medium and large process applications. Unlike conventional mechanical-type steam traps, Delta Venturi Orifice steam traps have no moving parts that can break or get damaged, and are still able to outperform conventional steam traps in lifespan and energy efficiency. The Delta range of steam traps have a lifespan in excess of 20 to 30 years, far outperforming any mechanical steam trap by many years. At startup, the water is at very low pressure and temperature, so no flashing occurs as it exits the Venturi. This means there is no back pressure present to restrict the flow of cold condensate as it exits the Delta trap. This cold water exits freely at 2 to 3 times faster than hot pressurized condensate can at running load. This absence of flash steam on startup is why Delta Venturi orifice steam traps are suitable for startup loads. Once all the cold condensate and non-condensable gases have been ejected, steam and hot condensate reach the Delta steam trap. As the steam continuously condenses to hot condensate in the pressurized steam system, it is fed to the steam trap by the pressure in the system. This hot condensate passes through the orifice and enters the mouth of the Venturi. As the condensate passes through the mouth of the Venturi, there is a sudden pressure drop, which causes a percentage of the hot condensate to change phase from condensate to steam, a phenomenon known as flashing. This flashing creates a back pressure zone in the mouth of the Venturi. Because condensate is 1,000 times denser than steam, it is able to push through this back pressure zone while restricting the steam. As the pressure and load in the steam system vary, so too does the percentage of flash steam being created at the mouth of the Venturi in the Delta steam trap, which in turn allows the back pressure at the Venturi to vary accordingly. This varying of back pressure at the mouth of the Venturi allows the Delta steam trap to self-regulate the condensate flow as the condensate load changes. As the pressure or load in the steam system rises or falls, the back pressure that is constantly changing at the mouth of the Venturi also rises or falls. This action gives the Delta Venturi orifice steam trap the ability to easily manage discharging varying condensate loads in a steam trap that has no moving parts, while still keeping the steam in the system. In summary, Delta Venturi orifice steam traps are designed to outperform all conventional steam traps through their unique Venturi design with no moving parts at all. Once installed, the Delta Venturi orifice steam trap will outlast and outperform any other mechanical steam trap in the same application.
All right. So just touching on some further cost savings. So once you've installed Venturi steam traps and they're tested and commissioned and working properly, there's no more ongoing specialized steam trap testing and auditing needed. It's because the trap is working and we guarantee it for as long as we do. You should never need to do any excessive steam trap testing and auditing. There's no more stock holding of steam traps and spare parts because you're not constantly replacing traps anymore. The labor is reduced of repairing or maintaining those steam traps. Less water treatment chemicals are lost through the savings on lost steam, and less boiler makeup water because of the reduced wasted steam. Just want to touch on a few success stories that we've had around the world. One of them is Donnie. It was a dairy plant in New Zealand, and they had ordered a 3-inch steam trap for a problematic heat exchanger that couldn't reach temperature. This had been going on for some time, and our distributor in New Zealand had proposed this to them. They'd accepted the proposal, but they'd insisted on a 3-inch trap. We took a look at the information and we sized a 1.5-inch trap for the same application, which was considerably cheaper. We made some modifications to the trap itself to fit the 3-inch flanges, and the body was a 1.5-inch trap. The results was a record heat-up time and process savings. So much so that Donnie had a number of plants across New Zealand. They not only replaced all the steam traps on that plant, specifically for those type of heat exchangers, but every single Donnie plant in I think it was 4 plants in New Zealand replaced all of their traps with Venturi traps because of those savings that they achieved, and the problems that they were struggling with on temperature went away quite quickly. And then just another one is did I say 4 plants? I think it says 2 more plants. Yes. So they ended up converting that complete plant into 2 more. So it's 3 plants across New Zealand. That was the photograph of that plant, the traps that came out. You can see, let me just find my pointer. Those are the ball float traps, the float and thermostatic, and that was the Venturi trap that was installed for the trial in its place. And then another story was Sasol, which was is a very large multinational petrochemical plant. A steam trap survey where 40% of failure across the total wax plant was identified. They did a trial of about 20 traps, 20 positions, and they replaced over 500 steam traps with a 3-month payback for that specific plant. To date, we've supplied over 1,200 traps across various Sasol plants around the country. And then ADNOC Sour Gas. ADNOC is the largest gas producer in the world. They're in Abu Dhabi. They had a 30% failure rate on their plant of over 20,000 steam traps. So that's a massive failure rate. We weren't involved in the survey. We just saw the results of the survey, and this is what was given to us. To date, we've supplied over 6,000 steam traps with an ongoing project to replace their steam traps. We've just received 2 orders from them for another 1,200 steam traps. So this is an ongoing project to replace all their plant steam traps with Venturi steam traps. And the payback of the traps supplied to date was less than 6 months that they achieved. And then
Bryan?
Yeah, Chris.
Can you talk about the ROI and what is that typical 3 to 6 month payback?
Yeah. So on failed steam traps, generally the ROI is less than a year, depending on the pressure and the steam costs. But often we do see returns of less than 3 months. If it's on just the failed traps, it's generally 3 to 6 months, but sometimes just over 6 months. If it's on complete plants, so you take all the failed traps plus some of the working traps, you tend to get a return of about 1 to 2 years. So they do that to eliminate the need to continuously replace traps along, so they replace the whole plant. So 3 to 6 months is what we see most often, but it can get up to a year, and then on complete plants, 1 to 2 years. All right. Just some photographs of some traps that were replaced. These are large process traps. This was a very large, I think this is a TLV float trap on a very large heating column. We replaced that. We made a special design modification for their pipework so that it would fit with their pipework. The Venturi nozzle itself is inside this body, and this was done as I said, on a very large petrochemical plant. There's a couple of traps that was replaced. These are just from different sites around the world. Some thermodynamic steam traps that were replaced. This is a video of one of our traps working on a plant. Let me just get my, there we go. And really what we're trying to show you here is often it's said Venturi traps just leak steam because they're just an orifice and they can't hold condensate back. And what can be seen quite clearly here is on the outlet of this pipe, this is a trap that's vented to atmosphere. You'll see there's drips of condensate and just flash steam escaping. Now, flash steam isn't leaking steam. Flash steam is normal. It's just the steam coming off the hot condensate as it goes from a higher to a lower pressure. If it was leaking steam, you would see pressure behind it, and it would be blowing down into the ground. So this trap is working very well. I think this was on a plant in Thailand that this site was done. And then yeah, that's just another thermodynamic steam trap that was swapped out on a petrochemical plant. And then again, a video on a petrochemical plant of a delta trap working to atmosphere. So you can see how it releases the condensate. what you're seeing again here is there's no huge amounts of steam coming through the trap. It's just a little bit of flash steam from the hot condensate that's coming in. All right, and then a large number of traps just fitted on a heat exchanger with different stages, and then something that we see quite a lot because of the way conventional steam traps work. You often need to put quite a large steam trap. This is a float type of steam trap, F&T trap. So it's got a big chamber where the condensate fills and then lifts the float and allows the condensate out. We replaced this, I think this was a 1.5 inch trap with a 3/4 inch trap in its place. And that's been running for a number of years now. There's a couple of those examples. These were F&T traps. I think these were 1.5 inch or 2 inch traps. Again, replaced. This was a 1 inch trap that replaced them. And then this was a plant. This is a big chemical plant in Thailand, where this F&T trap was replaced by a 1 inch trap. You see, they just flanged up the piping to allow the trap to work. So we can get away with a lot smaller traps. There's the once it had been installed. That's been in for over 5 years and running successfully. I was back at the plant earlier on in the year. We checked it, we tested it, and it's working beautifully. So that's my story. That's Venturi steam traps. And maybe if there's any questions, if anybody wants to ask, I'll leave the presentation on in case I need to go back to some of the slides. So Chris, I don't know if you've got any questions for me.
I do. About you had mentioned sized correctly. Can you discuss that a little bit as far as how that's determined and what goes into sizing a trap?
Yeah, absolutely. So what's very important for a Venturi trap is with every Venturi trap, we supply a nozzle, the Venturi nozzle itself, and that's got an orifice size, and that size is selected for the capacity and the range that application is working on. So for a drip leg, for example, we would select a specific size nozzle to go in the body of the trap. And to get that, we would need certain amounts of information. We would need the pressure. We would need to know more or less how many feet of pipe you're trapping. And we would need to know the pipe size that you're trapping. So 3 major bits of information. And then maybe, is it insulated, yes or no? So once we get all that information, then we select the orifice for that trap, for the Venturi. So that's the sizing that goes into it. If we size, this is potential downsides to a Venturi trap, and maybe it's one of the questions that might come up later, but the sizing is quite important. If that sizing is done incorrectly and we oversize, the trap can leak steam. So that's why we think it's quite important to, once installed and commissioned, the trap gets tested to ensure that it's not. If it's undersized, if we make that orifice too small, the trap can back up condensate. The traps generally have got a good range that they work in. So if we get the right information, we can size very accurately. We don't have a lot of issues with sizing, but that is something to note, that you do need a bit more information with regards to these traps to get the sizing right.
Got it. And there is sort of a related question, what you just mentioned. Are there any other disadvantages of Venturi traps?
I think the only other one that we would talk about is the upfront cost may be a little bit higher than a conventional trap on certain sizes. So maybe on the smaller sizes, the upfront cost is a little bit higher, but over the lifespan of the trap, the trap is considerably more cost effective. So maybe a higher upfront cost, but over the lifespan, it's definitely more cost effective.
And I guess the another question, this might be more for Donnie, and when it comes to surveys, you would that's where we would determine and help customers size their traps, correct?
Yeah, absolutely. That'd be part of the process of a survey or an audit for their steam system. At that point, we would gather that information from the site, do our pipe measurement lengths so that we can properly select the right or Venturi orifice for the trap that's going to go on that application, whether that be a drip leg. Obviously, pipe lengths between drip legs make a difference. And as Bryan mentioned, insulated or uninsulated, whether it's inside a facility, outside a facility, all has a direct impact on the amount of condensate that's formed from radiant heat losses. And then obviously detailed information when we're applying them on a process related trap, such as a heat exchanger or stripper column or something like that.
Thank you. I'll leave the chat open for a minute here if there's anything else anybody wants to ask.
And then if I could just add, and Bryan talked about it early in his presentation, and one of the unique features of the Delta line is the removable Venturi. Other people in this industry that provide orifice style traps typically have permanent orifices. So if they do misselect or a process condition changes, the Delta Steam line has the option of being able just to swap out the Venturi orifice while it's still in line, for a very quick change and an adjustment to match the new application or the new situation in the steam system.
Okay, I think that is everything. I'll pass it back over to Charlie.
Yeah, I would just like to thank everyone for attending this webinar. Thank you very much thank you very much, Donnie at MECTEC. Thank you very much, Bryan at Delta Steam Systems, for all the information that you provided. We just hope that everyone found this webinar helpful and informative. And if you have any other questions, please feel free to reach out to us. We'll be able to answer those. But thank you again to everyone that's involved and that attended.